What do we aim to teach you with this video? The answer is as simple as learning it. We're going to teach you to name hydrocarbons according to their structural formula and vice versa.
The UPAC nomenclature of organic compounds is a method used by the UPAC, the International Union of Pure and Applied Chemistry. The importance of the final rules is that ideally each hydrocarbon and its isomers will have its own name even if it doesn't exist. The most common hydrocarbons are alkanes, alkenes, alkynes, and aromatic compounds.
The simplest organic compounds are called hydrocarbons, and as their name suggests, they contain hydrogen and carbon. There are many types of hydrocarbons, like alkanes that contain at least one single bond, alkenes that contain at least a double bond, and alkynes that contain a triple bond. Cycloalkanes contain at least one carbon ring, and aromatics that contain at least one benzene ring.
Now I'm going to explain you alkanes. Alkanes are saturated hydrocarbons, which means that each carbon is bonded to another hydrogen. Like for example, each one has hydrogens. Okay. Now I'm going to teach you the steps for naming these compounds. First, you have to identify the longest carbon chain, which is also called the parent chain. Then you have to number each carbon in the parent chain, like for example 1, 2, 3, or 1, 2, 3. Name each alkyl group substituent. Like you have to name it according to the number of carbons they have. If the same alkyl group occurs more than once, use a prefix. For example, if it occurs only once, you don't use a prefix. If it occurs twice, you use D. If it occurs twice, you use 3. So, in the step number 5 is place the names alphabetically. So, the only thing you need to do is order them in an alphabetical order. And number 6, write the entire name, which will be the compound name. Now, I'm going to teach you some examples. The first one. The first step is to identify the longest carbon chain. So, here's one. 1, 2, 3. It's only composed of 3. Here's another one. 1, 2, 3, 4. It's only composed of 4. But there's another one that's larger. This one. 1, 2, 3, 4, 5, and 6. So, our parent chain will be this one. Now, the next step is number each carbon in the parent chain. It can either be 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. So the branch is nearest to this order from left to right. So we're going to number them like 1 until 6. Okay? So the next step is to identify this one, the branch. So as this group is on the second branch and it only contains one carbon, it is called methyl. So one of the last steps is to put the name alphabetically, but as it is the only one, you don't really have to order anything. So it will remain the second, as it is in the second carbon group of the longest parent chain, it will be called 2-methyl hexane. This is the name of this compound. Now I'm going to teach you to name this compound. The first step is to identify the longest carbon chain, which is obviously it's this one. So let's just circle it. Then the branches, which are these ones. So you have to identify what are they. As they are methyl, this is a methyl, and this one is a methyl. You have to number each and every one of the carbons in the parent chain. So this one will be 1, and this one will be 6, or this one will be 6, and this one 1. But as the branches are nearest from the left to the right, we're gonna use the numbers from left to right. So let's just make this one and this one. So this one, the methyl that's down here, it's on the second position, and this one is on the 1, 2, 3, 4, fourth position. And as there are two methyls, we're gonna use the prefix D for 2. So the name of this compound would be, as it is on the second and on the fourth position, it will be 2, 4 D methyl, and as it is 6, we're gonna name it hexane.
Well, I'm going to explain how to draw structural formulas for alkanes. And well, we can say that they are the opposite of how to name them. And well, basically you're going to use the name of the alkane to draw the formula. Here we have an example of the 3-ethyl-2-methylpentane, and this is the condensed structural formula, and this is the structural formula. The difference is that in the structural formula we are going to draw all the bonds, and in the condensed structural formula we are not, because we're putting hydrogens as a little compound in the formula. And well, you can see that this is a pentane because it has 5 hydrogens, and here is the ethyl, and the methyls are here. Well, this is an example of how to draw them. First, we have an heptane, which means that the longest chain is going to be of 7 carbons. And we're going to write it like this. Well, you have a 7 carbon chain, and well, we are going to complete it. They say that in the third space, that is this one in this case, because when we're drawing it, we are going to see why this carbon isn't available for the others. Well, we are going to say that this is our third carbon, and we're going to draw the ethyl, that is like this. Then we're going to go through the second space to draw the methyl. And then to the fourth space to draw another methyl. And then to the fifth space, that this is the reason that we are not going to put the ethyl here. Like this. Well, this is the condensed structural formula. To put the structural formula, you are just going to put the arrangement of the hydrogens as if they were bonded in another way to the carbon like this. A hydrogen here, 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 and here, here, and here, here, and so on. Well, this is it.
Yeah.
Well, and a last example of how to write structural formulas for alkanes. We are going to write 3,4-dimethylpentane. And well, here is the pentane. And well, we're going to number this chain as 1, 2, 3, 4, 5. And well, this is number 3. And this is number 4. And this is it.
Okay, today now we're going to talk about alkenes. Alkenes are very similar to alkenes, but they have one or more double bonds. And also when naming them, they have an I and E ending. The rules for naming them are very similar to alkenes, with the slight differences. First of all, the parent chain must have the double bond. Even if it's not the longest chain, it must have the double bond. Number 2, the position of the double bond determines how the chain is numbered. If we start from left to right, the double bond will be in number 4. But if we start from right to left, the bond will be number 1. So we will number it from right to left. 1, 2, 3, 4. When more than one double bond, because we only have one double bond, we will skip this step. Now, number 4, the numbers must be the lowest possible set of numbers. We already did that when we numbered from right to left. Now, the next step is to name these substituents. These are both methyl. And as we know from the previous set of rules for alkane, we have 2 methyl, so we need to use dimethyl. But we also need to say where they are. So we'll put 3 because this is in carbon 3, comma 3 because this is in carbon 3, hyphen dimethyl because we have 2, slash we need to number the double bond. We need to put the number of the double bond. The double bond is in number 1, so 1, and this has 4 carbons, so it's but, and it must have an I-N-E ending, so butene. This is a name for this compound. Okay, this is another example for an alkene. We know it's an alkene because it has a double bond. Okay, the first rule, the parent chain must have the double bond. So the parent chain is this one. It could also be like this, but it's okay. The position of the double bond determines how the chain is numbered. So if we name it from right to left, it will be 1, 2, 3, 4, 5. But if we name it from left to right, it will be 1, 2, 3, 4, 5. So we name it from left to right. We don't have more than one double bond, so we skip this step. The numbers must be the lowest possible set of numbers. We already have that. So first, name the substituent. This is a substituent, and it's called methyl because it only has 1 carbon. It's in the position 4, so it's 4 hyphen methyl hyphen. The position of the double bond, it's right here. So it's number 2. It has 1, 2, 3, 4, 5 carbons. So it's pen and the I-E-N-E ending. Pentene. So this is the name for this hydrocarbon. This is our last example for alkenes. First of all, identify the parent chain. Here is a double bond. So the parent chain, the easiest parent chain is this one. Now we have to number the parent chain. From left to right will be 1, 2, 3, 4, 5, 6, 7. And from right to left will be 1, 2, 3, 4, 5, 6, 7. So we'll name it from right to left. 1, 2, 3, 4, 5, 6, 7. Okay, we only have one double bond, so we skip this step. The numbers will be the lowest possible set of numbers. So we have this. Identify the substituents. This is ethyl. This is methyl. And this is propyl. Okay, we need to order them in alphabetical order. So first will be ethyl, then isopropyl, then methyl. Number the substituents. On number 5 is ethyl hyphen 3 isopropyl hyphen 2 hyphen methyl. Then we specify the number of the position of the double bond. We have it on 3 to 4, so we put 3. And we have 7 carbons, so it's an F-team with the ending E and E. And that's all.
Hi, today I'm going to teach you how to write the structural formula for alkenes. Well, the first step is to identify the alkene. Like this one, this is ethene. It has 2 carbons and 4 hydrogens. Then you need to write the carbons. As you know, alkenes have a double bond, so you can write a double bond here. Okay, now it tells you that it has 4 hydrogens, and each carbon can bond with 4 different elements. This carbon is attached to this carbon with a double bond, so it only has 2 left spaces. You write it here and here. And this carbon is also attached to this carbon with a double bond, so it has 2 left spaces for hydrogens. And here is the structural formula for ethene. Now I'm going to show you 2 more examples. The first one is propene. As you know, propene has 3 carbons. And the general formula for alkenes tells us that the number of hydrogen will be the double of the number of carbons. So we'll have 6 hydrogens. Okay, now the first step is to identify the alkene and then to write the carbons. In this one, it doesn't matter what the double bond is, you can go here or here, because alkenes are 2-dimensional hydrocarbons. Then it tells that it has 6 hydrogens. This one has 3 left spaces, so you write the hydrogens. This one has 1 left space, because it has a double bond with this one and a single bond with this one. And this one has 2 left spaces because it has a double bond with the other carbon. And here you have the structural formula for propene. Now we're going to write the structural formula for butene. Butene has 4 carbons and 8 hydrogens. So first we write all the carbons. Now I'm going to explain you how to draw the structural formula for butene. We know that butene has 4 carbons and 8 hydrogens. So the first step is to identify the compound, then we write the carbons. As I told you, it doesn't matter what the double bond is, it can go anywhere. Now we write the hydrogens. This one has 3 spaces left, so we write 2 hydrogens. This one has only 1 space left. This one also has 1 space left. And this one has 3. And here is the structural formula for butene.
Now I'm going to explain what alkynes are. Alkynes are hydrocarbons containing 1 or more triple bonds. The normal or regular hydrocarbons contain 1 single bond, 30 or more single bonds that are bonding with 2 electrons. Otherwise, the alkynes are bonding with 6 electrons. Now, okay, the longest chain. We need to count them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 6. So this is the longest chain. We need to circle it. Here we have the substituent. So, as we said, this is the longest part in the chain, and we need to identify the substituent. Where is it? So it's in the 1, 2, 3, 4, 5, and 6. It's in the number 4, so we need to put 4. And this is methyl because it has 1 carbon atom. And then we need to identify how many carbon atoms does it have. 1, 2, 3, 4, 5, 6. It has 6 and it's X. Okay. And we need to identify also where is the triple bond. So it's in the number 2. We need to put 2 and X. And we need to add this. Okay, here is another example, the last one. It's a number from left to right. Here it is 1, 2, 3, 4, 5, 6. It's the methyl because it has 2, and the positions are 4 and 5. So we're going to put 4, 5, the methyl. And it has 6 carbon atoms, so it's X. And the position of the triple bond is on the number 2, so we're going to put 2, and it has 6 carbon atoms, so it's X.
Hi, today I'm going to present you the structural forms for alkanes. We have to remember that alkanes have a triple bond and end with N. Well, in this case, I'm going to present you 2 types of structural formula. The first one, the structural formula. Here, we only can perceive the atoms and bonds, and the condensed structural formula shows atoms and the bonds between the carbons. Here's an example: propane. The condensed structural formula for propane is the following. Here you can see the triple bond. Well, this is the condensed structural formula, and here is the structural formula. It's very easy. You just have to expand the condensed structural formula. Three hydrogens, another carbon, the triple bond, another carbon, and the hydrogen that you can perceive here. Whoa. This is the condensed, and this is the structural. Here you just expand it. 2 more examples: the ethyne and the hexane. The condensed structural formula for the ethyne is the following: the triple bond, and the structural formula. Is this one. I just put the hydrogen here, but you can put it if you want here or use the same. Another example: hexane. The condensed structural formula for hexane is this one. Here's the triple bond. You just see the triple bond here. Well, and the structural formula is the following. You just expand it. Another carbon and 2 hydrogens. Another carbon and the triple bond. Another carbon, and here how many hydrogens do we have? 2, so we're going to put 2. And finally, the final carbon with 3 hydrogens. I hope that you understood how to name and conform the structural formulas for alkanes. Thank you.
Okay, now we're going to talk about aromatic compounds. Aromatic compounds are the compounds that have a benzene ring. They can be written in this form, putting the bonds, or in a circle because the bonds are constantly moving. They are very stable. With compounds that have one substituent, you only put the name of the atom and benzene. Claramente.
Sí,
Yeah.
sí, ya.
With compounds that have two substituents, we have three options. We can use numbers. They need to be in their lowest form. In this example, you have two methyls in 1 and in 2. So it's 1, 2 dash dimethyl benzene. You can use the common name and the prefix. In this example, we have 1, 2, 2, 3, and 4. The prefixes are that if we have in the substituents in 1 and 4, we use para. So we use a P, and we put that ethyl is in number 4, and this is totally taken as the parent chain. Or we can use the third option to use only prefixes. It's the same example. It's para, methyl, ethyl, benzene.
A hydrocarbon derivative is an organic compound that instead of a hydrogen, it has another element. In this case, you will see a halogen, but it can be a hydroxyl group, or another kind of halogen. This is an Romo